Hey everyone, in this video I'll walk you through how to set up Git in our local system and push our network automation project to GitHub. So Git helps to track our project history so we never lose a working version of our code. So in our previous two videos we built a solid foundation. So we installed EVNG on Windows, deployed virtual routers, we also set up Linux node and installed Ansible on top of Python. So in this part 3 video, we'll explore how to set up Git from the ground up, configure the Ansible properly and write your first playbook and automate the router configurations. Then we'll implement the version control best practices by pushing everything to GitHub. So there is a lot to learn, so make sure to watch till the end. And if you find this video helpful, please don't forget to like and subscribe. It really helps more people to discover this content. Alright, let's get started. So remember we built out this awesome lab environment with 3 virtual routers and a Linux node, all connected through a switch, and the switch is connected to Cloud Zero, which gives our management access. So pretty standard setup. So let's fire this up. I'm going to power on the EVNG host from the VMware workstations. Then we'll jump into the browser to access our virtual lab. Now here is what we are going to tackle today. We are going to configure these virtual routers through Ansible, and this is where the automation really begins. For that we need to make sure the Ansible can talk to our devices. So Ansible need an SSH transport to talk to all the managed devices. So we need SSH access set up properly first. So we are going to apply some basic configs on these routers. So first we need to configure the host name. Obviously it give a unique host name for all our routers, and we also put the domain name. This is required to generate the crypto keys. Then we are going to generate a crypto keys where we are going to set up 2048 bit length because of enhanced security. We'll also set up a local account with the privilege level 15. This will give a full access for Ansible. We'll also configure SSH on VTY lines, set up the local authentications, pretty standard stuff. Finally, it's a good practice to change the IP assign from the DHCP to static to avoid any unexpected IP changes. So this is a core configuration needed on all devices. Let's apply these changes across all 3 routers and save their configurations. So now we have set up all our devices with SSH access and we are able to ping the gateway successfully. Now we will move to the next phase of our video where we are going to see how to set up Git. So in layman terms, Git is like a save button in your project that remembers every changes you make. It helps you to go back if something breaks and let you to work with others without messing things up. It also keep your work safe and backup so you don't lose anything. So let's see how to set up Git in our Linux node. For this, we'll jump to the Linux node we added in our previous video. So once the Linux node is fully booted, we'll access it via VS Code and start the Git configuration. First thing, let's make sure we have the Git installed. Open the terminal in VS Code and run git-version. So we don't have a Git running on this node. So let's go ahead and install them first. It's a small package and shouldn't take long. Now we need to configure our username and the email address. So let's check if there is any existing configuration with a git config list command. So every commit we make gets tagged with your name and email address. So that is how Git tracks who make what changes. So let's add this information. Alright, so Git is configured locally. So now let's go over to the GitHub page, log in with your GitHub account, and here we'll see how to handle the authentication piece. So here are the things. So we need to have a secure authentication between our local machine and GitHub. So without this, GitHub will just reject our push and need to verify you are actually allowed to push code to that repository. So we got two options. First one is HTTPS. It uses GitHub username and personal access token. So GitHub will prompt you for a credentials every time you push. Then the second option would be SSH. This is the most recommended methods. You can generate SSH key pair on your local machine and add the public key on your GitHub account. And GitHub will authenticate you automatically using the key pair. So this is much smoother workflow. So we are going with SSH for this demo. So back in the terminal, let's generate an SSH key pair first. Run RSA key generation command with a key length of 4096. We can also use -c if you want to put some reference to this key. You will find all these commands in the video descriptions so that you can easily follow along. Press enter to accept the default location of the key. For passphrase, you can skip it for now by press enter or set 1 if you want an extra layer of security. Next, we need to copy our public key and add it to the GitHub. Copy everything starting from SSH-RSA and head over to the GitHub, go to the settings, go to SSH and GPU keys, create a new SSH key, give a name, paste your key there and save it. To verify everything working, let's run the agent on our local machine and add our private key. We can test the SSH connection with ssh-t git@github.com. So you should see all the welcome message confirming the connection and the GitHub recognize your machine now. So that's it. You are authenticated now. You can clone the repositories or push your local projects to GitHub, which is exactly what we are going to do next. Now let's jump into the Ansible project creations. But before that, let's fix a few things that will help in your home lab. So after configuring SSH on routers, we will test the connectivity from Linux node, which is the Ansible control node. So you'll notice the SSH session fails as Ubuntu use newer SSH algorithm that aren't supported by the devices. So I got an older iOS versions running on my routers. So we'll fix this by updating the SSH config file to support the older algorithm. And we'll also update /etc/host file for the DNS resolution so that we can reset devices by host name. Now let's go to the project folder. Remember, we have an alias created called netdev that will go to the Python virtual environment inside the Ansible project directory. So let's run the first git command, which is git init. So when we run this one, git creates a new empty repository in your current directory by initializing a hidden .git folder that containing all the necessary metadata and the structure of version control. And it keeps track of all your files and changes in that folder. So let's run the git status command here. It says our branch is master, no commit done yet, and there is one untracked file inside which is ansible-venv, which is the virtual environment created in our last video. Perfect. Now we'll jump in and see how to create an Ansible project. So I have covered Ansible project much details in a couple of videos in the past. So in this demo, I'll cover a basic structure to automate loopback creations on all our routers. So to start off, Ansible has a project structure where we need to have an inventory file, playbook, group vars and host vars. So let's go ahead and create those first. And we'll create an ansible.cfg file where all the key configuration goes in. We'll also create a host file for the inventory management. Great. So this is the basic Ansible structure look like. Let's update the ansible.cfg with inventory location, privilege level and SSH connection arguments. This is a pretty standard configuration. Similarly, we'll also define the host details by creating a routers group, provide the device credentials for SSH and the connection method. Now if we run the Ansible version command, you can notice it picks the local Ansible configuration we just created. Now let's run the ping to the routers group using the Ansible built-in ping module. And we can see the success response from all three devices. Awesome, we are good so far. Now let's create a playbook in YAML. So first let's give a description where we want to configure the loopback interface for all devices. Next we'll define the group where we want to push these changes. So we have created a group called routers under the inventory. We'll call the same here. So we'll also invoke the iOS configuration module to update the description and the IP address details. So IP address will be a variable here since it changes on every device. So this is a simple and neat playbook example. Now let's define the loopback for each device. This can be done through host vars directory by having individual files created for each host, or it can be defined on an actual inventory host itself against each host entry. So let's go ahead and update this one on the host file itself. Alright, we have all the standard Ansible project structure now. Let's go ahead and run some tests. First, we'll do a syntax check with Ansible-playbook command, and we don't see any error while running this one. Let's also do a dry run using check command. While running the playbook, it says that we don't have Paramiko installed. So let's quickly install this using the pip command since we are inside the virtual environment. So when we run the pip list command, we can see the Paramiko has been installed inside our virtual environment. So let's run the dry run again, and this time no failure while running this playbook. Finally, let's run the actual playbook to make the changes on the devices. Now we can see that the changes has been successfully done through Ansible. We don't see any errors while running this playbook, and the total number of changes is 2. Let's go ahead and verify this on the device. So let's verify this using the iOS command module, and we will send show IP interface brief command and use routers group to all devices. Now we can see each device has new loopback created along with its IP address. And we can also see these updates on the device configurations as well. Alright, so in a nutshell, we have created an Ansible project and tested the automation successfully. Alright guys, so before we wrap up, let's quickly go through the Git workflow. And I'll try to explain this using the Ansible project as an example. And we'll see how our code moves from local computer to GitHub in 3 simple steps. So let's start here at the working directory. This is simply your project folder on your computer where you create and modify the files like Ansible config, playbook.yml, invent host vars and group var folders. Now there is 3-step workflow to get your code to the GitHub. Step 1, git add. So when we run the git add, you are moving your changes from working directory to the staging area. Think this as a preparation zone. You are selecting which files are ready to be saved. Next is git commit, followed your message. It takes everything from your staging area and create a permanent snapshot in your local repository. This is saved on your computer with a descriptive messages about what you changed. Finally, we got a git push which upload all your commits from your local to the remote repository on GitHub. Now your whole team can access your work. So these 3-step workflows gives a complete control. You can stage your specific file, commit related changes together with a meaningful message, and only push to the GitHub when everything is tested and ready. So let's see this in action from our console. So we are inside the project folder. Let's run the first command, which is git add. And if you want to stage a specific file, you want to provide the name of the particular file. Since we have multiple files to stage, we are using git add dot. This will stage all the files for the initial commit. Remember, if any folder is empty, git won't track that folder. Git actually track the files, no empty directories. So next we'll commit these changes to our local repository. So to do that, let's run git commit followed by a meaningful message. So we'll use Ansible -project initial commit as our message, and a commit ID will be generated to track this commit. So while the commit is in progress, let's go to the GitHub and log in with your account and create a new repository to store this project. We'll give a repository name and change the visibility mode to public, and we won't add any default files like readme right now. Here you will see a couple of commands that can be used to push to the remote repository. We can choose between HTTPS and SSH. Since we already have SSH established from our local machine, we will go with SSH option. Now back to the terminal, our commit has been completed, but if you look closely, there is an issue here. While committing everything, it includes our virtual environment file, which should not be pushed to GitHub. So this is where git ignores comes into the play. So git ignore blocks certain file from being tracked. So this is important. So some of the files inside Ansible virtual environment, log files, retry file should not go to the GitHub, right? So in the terminal, let's create git ignore file first. We will list, maybe we can give slash Ansible hyphen venv slash, that will cover all the files inside it. You can include retry and whatever you want to ignore here, and git will completely ignore these files. Will never enter into the workflow. Since our project is already committed, we also want to run this command to remove all the Python related files from previous git tracking. Now let's stage the git ignore files using git add command. Now we'll do the second commit to remove all the Ansible virtual environment file from the git tracking and save these changes into the local repository. So while running this command, you can see it deleting the Python files in the virtual environment packages from the commit history. Excellent. Now let's go back to the GitHub and choose SSH option, which lists all SSH related push commands. So copy the first command to add the remote repository link to our local machine using git remote add origin. Also set the branch as main. And finally, push our files to the remote repository with a git push command. So in summary, we have committed our changes twice and pushed the final version to the repository only once. You can also check the log messages for specific files by entering git log followed by the file name. And if you look specifically at Ansible venv folder, we can see the two commits occurred, the initial commit, then the git ignore file added during the second commit. Now let's head back to the GitHub, and you can see all the files and folder have been successfully pushed to the repository. So that's pretty much everything I want to cover in this video. I hope you have a clear understanding how to do this, and I highly recommend trying this out in your home lab and share your feedback in the comment section. And I'm happy to share if you need any assistance. And if you found this content valuable, please hit the like button and subscribe to this channel for more such content. And thank you for watching, and I'll see you on the next video.